Okay, in this video, we're going to discuss how we can actually fine-tune the pre-trained models for our application. In the last video, we talked about common pattern for using Hugging Face transformers. We talked about how we use tokenizers and the process of tokenization. First of all, this raw text becomes a list of input IDs. And then we need to add special tokens at the front and at the end. And we used our models, and using these pre-trained models was quite easy. Okay. And we also visualized the attention maps from this model. And what we're going to talk about now is fine-tuning. And for fine-tuning, we first need to prepare a data set. And I showed you this website, huggingface.co/models. And this Hugging Face also offers a variety of data sets. So if you click this data sets, the URL is like huggingface.co/datasets. And there are multitudes of data sets already available. Many famous companies and universities are offering their own data sets like Intel, EPFL, NVIDIA, Berkeley. So you can use these data sets already. And how can you use these data sets? That's quite easy. We installed data sets. And from these data sets, we import load dataset package and dataset dictionary. And let's just assume we want to use the dataset called IMDb. And as we did for loading pre-trained weights, we just call this function and just specify the name of dataset, IMDb. That's all. Then it will automatically download dataset and it will prepare this dataset for us. That's all. Very easy, right? And here, as an example, I'm going to show you a function called truncate. Because this IMDb, this dataset is about reviewing movie reviews. And these reviews can be sometimes very long. And we're going to truncate those reviews into 50 words. So what we are going to do is the text becomes the first 50 words. And label remains the same. Okay, this is the truncation, another preprocessing we're going to apply. And this data set is quite big. And for our demo purpose, we're going to just retrieve the first 160 examples. And for this purpose, you can use dataset dict. And here you specify the train dataset, IMDb dataset, train. And you can perform a lot of operations like shuffle. And you can also select 128 samples. And you can map this truncate function. And we are going to define the validation data set. We're going to select from 128 to 160. Okay. This should be select. Okay, and then let's see what this data set looks like. This data set features text and label, and we have 128 samples for training. And for validation, we have 32 samples. All right. And let's visualize the first sample. This one operates just like ordinary dictionary. So you can just access to these properties in this way as you do for dictionaries. This first sample contains this text, probably Jackie Chan's best film in the 1980s and the one that put him on the map, blah, blah, blah. And as you can see here, it goes beyond this text. However, because this is very long, we just truncated this sample into 50 words. And you can visualize more like this. Okay. And we cannot use this data set at current level for training. What should it do? We should tokenize this sample and turn these words into the list of IDs. How can you do that? That's very simple. We're going to just map our tokenizer. So we pass our tokenizer. And we're going to add padding and truncation true. We're going to make it batch, and the batch size is going to be 16. And you can manipulate the columns, like remove columns. And rename column, label into labels. And you can change the format as PyTorch tensors. And when we visualize the first sample, then it becomes a list of IDs. As you can see here, the first one is the CLS token, and the last one is separation token. Okay, and it also gives attention mask. Only this part, up to this part, is meaningful part. Okay, and this is how we use dataset. Sometimes you might want to define your own dataset. If that is the case, if you don't want to use these predefined dataset, what you can do is go to this docs, and here you can see these datasets. By looking at this documentation, you can see how you can define your own dataset. Okay. All right, now we have our datasets and models. What's the next process? We need to train. Our transformers already provides all kinds of training utilities, like these optimizers and learning rate schedulers, like this. You can use these. And we need another step. Oh, we don't need another step. Yeah, we already defined the data set. We also need to import training arguments and trainer. I told you in the previous session that nowadays many frameworks provide this trainer package where you can just define the training argument and just pass that training argument to this trainer, and this trainer will take care of all the training processes. Okay. So here we're going to define the model is still BERT or sequence classification from pre-trained is still BERT base case. And we also need to define the number of labels. And we're going to define the arguments, training arguments. And this is quite easy. We just specify the dictionary that we want to store the trained model with. Sample Hugging Face trainer. And per device, train batch size. Here, device means GPU. If you have multiple GPUs, like 4 GPUs, then the batch size is going to be 16 times 4, which is 64, okay? However, if we have just 1 GPU, then the batch size is going to be 16. So here, device means GPU. Or device eval batch size, also 16. And we can specify the number of training epochs as 3 or 4, whatever you want. Evaluation strategy as epoch. You can use also iteration. However, here we are going to use epoch. Save strategy. So at the end of each epoch, we'll store the trained weight. Okay, and we can specify the learning rate and load best model at the end. True. And seed 2 to 4. Okay, like this, you can specify the training configuration. And we need to provide how we are going to evaluate, what evaluation metrics we are going to use. We are going to use accuracy, so we need to define this function. This is the model output, okay? And this is the label. And the accuracy is going to be the mean of the correct predictions. And after this, we define trainer by passing the model we want to fine-tune, and arguments using these arguments. And train data set, we already defined these train data sets, small tokenized data set. And eval data set. And we also need to pass tokenizer and compute metrics, pass this function. Then this trainer in the evaluation process will use these compute metrics to print out this accuracy, okay? And after this, training becomes very easy. After defining this trainer, you just call this train method. Then, because it takes quite a long time, I will not run this code, but you can run this on your own. Then it will just print out the training process, like the accuracy and the loss and other information. Okay. Then, how can you use this trained model? There are two ways. We can just pass a data set like this. Then it will give the results. Okay. And this is when you want to pass multiple data. And another way, we just define this pre-trained model. And this is the directory that we want to store the pre-trained weight, fine-tuned weight. Then under this directory, checkpoints are going to be created like this. Then you just pass this checkpoint 24. Then you can use this model as we did for pre-trained models. And we define test input. I enjoy the movie like this. And to this fine-tuned model, we just pass this input. And we can get predictions. Okay, so using these Hugging Face transformers for as it is quite easy, and fine-tuning is also very easy. We just need to configure the training parameters and just pass these parameters as arguments, and this trainer will handle the training process. Okay, and we talked about this trainer class in the previous sessions, so I guess it's quite easy and familiar to you. All right, this is the end of Hugging Face Transformers tutorial. And yeah, this is the end of this session. Let's call it a day.